Can you feel a solar wind?
Our star, the Sun, is the source of light and heat for us here on Earth, but it has other more subtle effects as well. The Sun produces a kind of wind, one that is very different from the breezes that we're all familiar with. Unlike winds on Earth, which are circulating air currents, the solar wind starts in the outer layers of the Sun. There the temperatures are so high that the hydrogen gas atoms are broken up into electrons and protons. These charged particles are churned up by the Sun's strong magnetic field and are flung out through the solar system, forming this wind. Occasional outbursts on the surface of the Sun, like this solar flare, greatly increase the strength of the solar wind. So, can we ever feel this wind? Well, down here it turns out we're very well protected. Long before the solar wind ever reaches the ground, it's deflected by the Earth's magnetic field. Some of the charged solar wind particles can make it through near the poles, but are stopped by the atmosphere, producing beautiful nighttime displays of aurora. Spacecraft that operate beyond the Earth's magnetic field have no such protection, and their sensitive electronics can be disrupted by the solar wind. Therefore, these spacecraft must be built with durable electronics that can survive long-term exposure to this radiation. So, even though we can't feel the solar wind, we do experience it indirectly through its effects on the atmosphere and our artificial eyes and ears in deep space. For Ask an Astronomer, I'm Dr. Robert Hurt of the Certus Science Center.
Do other solar systems exist?
Until very recently, we didn't know of any solar systems besides our own. Because planets don't shine by their own light, but merely reflect the light from their host suns, the much smaller planets appear very much dimmer than the stars they orbit. These planets are lost in the star's glare and can't be seen directly. If we can't see them, how do we even know other planets exist outside our own solar system? Well, planets, like all other objects in the universe, exert a gravitational tug on other objects nearby. In a solar system, a planet tugs on its host star, and this tugging causes the star to wobble slightly as the planet orbits it. Astronomers use powerful instruments and telescopes to monitor nearby stars for possible wobbles. To be more exact, imagine the star and its orbiting planet as a very lopsided dumbbell. The two objects orbit around the balance point of the dumbbell, which is very close to the star since the star is far heavier. The planet orbits the balance point in a wide circle, and the star in a much tighter circle. As the star moves toward our line of sight on its tight circle, the wavelength of the light coming at us becomes compressed, shifted to the blue. As the star moves away from us on its circle, the wavelength of the light gets stretched out, shifted to the red. The blue shifting and red shifting of the light caused by the star's wobble is known as the Doppler effect. So, even though we can't view the planet directly, we can detect this Doppler effect in the star and reveal the presence of the planet itself. Using this technique, astronomers have detected planets around many dozens of nearby stars. For Ask an Astronomer, this is Davey Kirkpatrick at the Infrared Processing and Analysis Center at the California Institute of Technology.
Are other solar systems like our own?
Some nearby stars, like our Sun, have a family of planets in orbit around them. Take, for example, the star 55 Cancri in the constellation Cancer of the Crab. It has at least 3 planets in orbit around it, one of which is 4 times heavier than Jupiter and orbiting the star at the same distance as Jupiter orbits our Sun. Its other 2 planets, one as heavy as Jupiter and one as heavy as Saturn, orbit very close to the star, as close as Mercury does to the Sun. The star Upsilon Andromeda in the constellation Andromeda, the chained maiden, has its own family of at least 3 planets. Unlike our own solar system, however, Upsilon Andromeda has a second star in orbit around it. This other star lies about 20 times further away from the main star than Pluto lies from the Sun. Other solar systems are much more exotic, with massive planets that plunge toward their host suns on much more extreme orbits. The star HD 80606, for example, has a planet 4 times heavier than Jupiter, which travels on a very unusual orbit, plunging 10 times closer to the star than the planet Mercury orbits the Sun, then swinging wildly out to a distance equaling that between the Earth and the Sun. Even though astronomers are uncovering an exciting variety of solar systems around nearby stars, one ultimate goal still eludes them: finding a planet like the Earth. We're not able to detect any Earth-sized planet with current methods, but planned NASA missions are being constructed to uncover other Earth-like worlds. Stay tuned. For Ask an Astronomer, this is Davey Kirkpatrick at the Infrared Processing and Analysis Center at the California Institute of Technology.
Do the stars really move?
Since the dawn of time, people have looked up and watched the stars move across the sky throughout the night. In ancient times, people believed the Earth stood still and the stars rotated around it on the inside of a giant sphere. But then in the 16th century, a new idea was proposed by the astronomer Nikolai Copernicus. Copernicus suggested that the apparent motion of the stars was caused by the movement of the Earth. As the Earth turned each night, the stars tracked across the sky. And as the Earth moved around the Sun, the nighttime constellations, those we can see at night in the direction away from the Sun, also changed. Well, that seemed to be it. It was clear that the movement of the stars overhead is an illusion. But then, in 1718, astronomer Edmund Halley looked at the position of several stars that had been recorded by the ancient Greek astronomer Hipparchus of Rhodes. Halley realized that the stars had moved a little bit relative to each other since Hipparchus had measured them nearly 2,000 years earlier. It wasn't until the 20th century that this all started to make sense. Now we know that we live in a galaxy. Stars in all galaxies actually race around a central core like race cars speeding around a circular track. Our Sun moves at over 160 miles per second and takes over 200 million years to go all the way around the galaxy. Since the Sun's birth, the Sun and Solar System have done about 28 such high-speed laps, always keeping up with the competitors. We can't see this motion because the stars are so far away. It's the same as if you look at an airplane. If an airplane is close by, it seems to move very fast, but an airplane flying at 30,000 feet seems to move very slowly, even though they're both moving at the same speed. Stars that are at different distances from the Earth will also reveal their motion over long periods of time. And like the two airplanes, the stars closest to us will appear to move more quickly. So, do stars really move? Well, their motion wending their way across the night sky is an illusion caused by the spinning Earth, just as the Sun is seen to move during the daytime. But all the stars are moving terribly fast, including the Sun and the Earth, speeding around the center of the galaxy in circles like race cars. For Ask an Astronomer, I'm Dr. Steve Lord at NASA's Infrared Processing and Analysis Center at the California Institute of Technology.
What is a redshift?
Astronomers often use the term redshift to describe how far away a distant object is. To understand what a cosmic redshift is, think about sound. Sound travels in a wave. You hear the engine of an airplane because the waves travel through the air to your ear. If the airplane is moving, the sound waves in front of it are compressed, creating a higher frequency sound. The sound waves behind it stretch out, creating a lower frequency sound. As the airplane passes you, you will hear the familiar Doppler shift. Light also travels in waves, and a similar thing happens to these waves. Light waves are able to compress and stretch, thereby changing their frequency or color. Blue light has shorter wavelengths than red light. When an object in space moves towards us, its light waves are compressed into higher frequencies or shorter wavelengths, and hence we say that the light is blue shifted. When an object moves away from us, its light waves are stretched into lower frequencies or longer wavelengths, and we say that the light is red shifted. So, how does redshift define distance? Well, the light from most galaxies in the universe is redshifted, as seen from the Earth, because the universe is expanding. It turns out that the farther away a galaxy is, the faster it's moving. And the faster a galaxy moves, the more its light is redshifted. So measuring the amount of redshift is a good measure of the distance of the galaxy. Using this cosmic redshift, astronomers have measured the distance of galaxies as far away as 12 billion light years. And we're always pushing that cosmic limit farther back. For Ask an Astronomer, I'm Dr. Tom Jarrett at NASA's Infrared Processing and Analysis Center.